Okay, so everyone is here for the Intermediate Algebra Exam 3 review. This is version A. And if you want to take a look at the exam that we're going to be working through, well, the review, I should say, go into our course, our online course, which many of you are already in because that's how you got to this Zoom session. Click on Algebra, Test Review Materials. Ignore iMath.AS, you need the My Math Lab. And right here is version 3 that we are getting ready to do, or version A, I should say, exam 3. So the solution guide will be posted pretty soon because we're going to be working on that as we answer these questions. And the video will be posted as soon as Zoom uploads it into the cloud for us to put out here. So this video will be the Zoom video, the video that goes in here. So there's all of your information. And right there is the exam. You can, my advice to you is to download it onto your computer, because if you open up the window view of it, it crams it all right in here. So it says error fetching session, weird. So I would just download it, but I'm gonna have it up on the screen as well too. So let's get this party started. And I didn't screen share that at all. Yay. You guys should have said something. So let's talk through that again. So again, we're all here for exam 3 for intermediate algebra. So you go out to your Canvas, which all of you have done this. If you're looking for the exam that we're going to be looking at, so go to our online math resources. You're going to open up intermediate algebra. And you go right over here to test review materials. And you're going to click on My Math Lab Review. Exam version we're looking at. Again, I would just click on this, download it to your computer. Right here is where the solutions that we're going to be making during this video will go. And right over here is where the video that we are recording right now in Zoom is going to go. So all that will be uploaded as soon as we're done, and it's uploaded into Zoom. Everyone good so far? Is everyone still with me?
Yeah.
Yeah.
Okay. Just wanted to make sure, because my computer's kind of slowing down and doing some weird things right now. All right. So let me close that window. Here is our review, version A. So let's get started. So the first thing it says is we've got this function. It's 5x all over 5x minus 3. And we want to find the domain. How do we find the domain of rational functions?
Number one, print this.
Say it again. How do we find the domain of rational functions?
I don't work on Mondays.
Well, I don't work on Mondays either. Just kidding. I'm working right now.
Today. I have to work. One for going 7 p.m. and one at midnight tonight.
Rochelle, you're talking to us out loud.
Really?
Yes, we can hear that you don't work on Mondays. So how do we find this domain? Talk to me.
Set it to 0.
Set what to 0?
The denominator.
Good. We're going to take that denominator and we're going to set it equal to 0. So we've got 5x minus 3 equal to 0. All right. So then what do we do now?
Add 3 to both sides.
Okay. So you're getting the x by itself. So 0 plus 3 is 3. And then last but not least, what are we going to do?
Divide by 5.
All right, we divide by 5. So we now know that x is equal to 3/5. And we don't want the decimal. So what do we do with this then?
Put it in the union.
Put it in the union. Well, let's go and let's see what kind of answers they want. So here, it says that we're going to fill in the box below with our answer choice. And this is set notation.
Okay, so then just put 3 over 5.
Just put 3 over 5 in the box. That's right. Because in set notation, I get what you were telling me. Because if we did interval notation, because I taught you that, it would have looked like this. Parenthesis, negative infinity to 3 over 5, because we do not like this number. This is the number that creates 0 up here, and we can't divide by 0. Union, 3 over 5, all the way out to positive infinity. But they want set. And set's pretty easy to do. You put your little squiggle, your X bar, and then they put in that X is a real number, which is fine. But you don't have to because we know that we're working with the real number system. Put your X equal 3 over 5, and then a slash through the equal sign. So the 3 over 5 is really what goes in the blank. Yeah, don't use the union symbols because they don't want interval. They're really after set. So we come over here and we select A and we put 3 over 5 in the blank. All right. Question 2, same thing again. We're going to give you this function R of X, and it's equal to 8 plus 6x all over x cubed minus 8x squared minus 9x. So how do we find the domain of this again?
You're gonna have x to the third minus 8x to the second power minus 9x equals
Equal to what? What was that last part?
equal to 0.
You got it. Equal to 0. Because we want to know when this is 0 down here. So what do we got to do to this?
You're gonna not factorize.
No, you're right. We got to factor it. So what's the first thing we're going to do to factor this?
Look for the LCD.
Not LCD. We're thinking factoring.
What's common to the 3 numbers?
Yeah, look for that GCF. So is there anything in common across these 3?
An X.
X.
An X. Good. Yeah, you guys got it. Sorry, I was trying to check something out. So if we pull that X out, what are we left with inside?
X to the second power minus 8x minus 9.
Okay. And now what are we going to do with this? This x squared minus 8x minus 9.
I don't remember.
Got to continue to factor. Because this will continue to factor for us. So the question is, what does it factor to?
X minus 9, X plus
You got it. X minus 9, X plus 1. And now that it's completely factored, what do I do with all this?
Group them and equal them to 0.
You got it. Take them and equal them to 0. Don't group them, just separate them equal to 0. So we've got our GCF here that equals 0. We've got our X minus 9 that equals 0. And we got our X plus 1 that equals 0. Okay, your GCF is just like all these guys. Remember, we have what is called the zero product rule, where the zero product rule says that we can take our parentheses and set them equal to 0. The GCF, it does have a parenthesis around it. We just normally don't put it, but there is like an invisible parenthesis there. So all my parentheses get set equal to 0, even the GCF. So when we look at this, is there any solving here? When we look at this X equals 0?
No.
No. So that's one of our answers. We don't like 0. What are we going to do to solve X minus 9 equal to 0?
You're going to add 9 on both sides.
Okay. So X is equal to
Positive 9.
positive 9. So there's another one of our answers we want. And then how do I solve X plus 1 equal to 0?
Minus 1 on both sides.
Okay. So X is equal to
Negative 1.
negative 1. So if we were doing interval, which is not what we want, interval would have looked like this. Parenthesis, negative infinity to our first number, which is negative 1, because that's our lowest.
A negative 1.
Parenthesis, union, parenthesis, negative 1. And then we travel up to our next number, which is 0. Parenthesis, union, parenthesis, 0. And then we travel up to our next number, which is 9. Then union, parenthesis, or parenthesis, union, parenthesis, 9 to infinity. That's what it would look like if it was interval notation. But we don't want interval notation. We want set. So in set, we'll do our squiggle, our X bar, X not equal to what?
negative 1 and 9.
Negative 1, a little bit more than just negative 1 and 9.
Plus,
Don't forget,
Squiggle.
infinity.
no, right here,
0.
0.
Okay.
We don't like negative 1, we don't like 0, and we don't like 9.
9.
Okay, there were 3 numbers we don't like. 0, negative 9, or sorry, positive 9, and negative 1. And that's what they're looking for in the blank.
Can you hold it there for me, please?
Yeah. Again, they don't want the interval, but I taught you guys how to do interval. That's what interval would look like. But the set is the most important.
It's the Armstrong, like you're on that page. Can you go back a little? Let me see the set for the first one.
The set for the first one? Yeah.
Thank you.
So when you go back to your exam, right in here, you'll put negative 1, comma, 0, comma, 9. And that's it. Make sure you select A. All right. So Now, number 3. So it says simplify this rational. So how do we simplify rationals? What do we got to do first? For this 3x squared minus 10x minus 8 all over x squared minus 7x plus 12. How do we simplify?
I'm gonna look for the two numbers that give you the negative 10x.
Okay,
Factor.
so you're trying to factor. All right. So what does this numerator factor to then? That's the question.
You're gonna use x
What do you mean I'm going to use x?
as the common. No, it's not common to 3.
What does this 3x squared minus 10x minus 8 factor out to?
3x plus 2, x minus 4.
You got it. 3x plus 2, x minus 4. Anything about the denominator?
Yeah,
Yeah. So it factors as well. What does it factor to?
x minus 3, x
So
minus 4.
x minus 3, x minus 4. I like it. Yeah, remember the first thing with simplifying, you got to make sure everybody's factored. Because once it's factored, now we can see what's going to go away. Who's going away? Who's getting canceled out?
X minus 4.
Yeah. So we got an x minus 4 on top. We got an x minus 4 on bottom. Gone. And then all we got to do is write down what's left. So what's left?
3x plus 2 over x minus
You got it. There's your
3.
answer. 3x minus 2 all over x minus 3. Perfect. Good job. That's simplifying. Yeah, your factoring is going to take you the longest on this. Factoring is the long part. All right, so let's jump back into our exam. Oh, another simplify the rational. This time we have x squared minus 100 all over 10 minus x. So what do we do?
X plus 10, x minus 10.
Good. So this is just a difference of squares on the numerator. You get x plus 10, x minus 10. What about the denominator?
You're gonna have negative x minus 10.
Negative x minus 10.
Yes, sir.
How
The
did you
negative
get?
outside and open bracket x.
Oh, okay. So pull a negative out of this denominator.
Yeah.
Yeah, absolutely. Yeah. So you said negative 1 and then a parenthesis x minus 10. I gotcha. Yeah, and you're right. Because these two almost match, The problem is the signs are off. And we talked about when they almost match, but their signs are off, just pull out a -1 and that will reverse the signs. Perfect. Good job.
So we have to always,
You have to always what?
so we always have to put a -1, or we could just put negative.
Yeah, you could put just negative parenthesis x minus 10 parenthesis.
Okay.
All right. So what's canceling out?
X minus 10.
All right. Gone. Gone. What's left?
X plus 10 over -1. Or just
All right.
negative.
So this is correct, but what my math lab will probably want you to do is they don't want you to have the negative necessarily in the denominator, but this is correct. Don't get me wrong. This is just fine because the negative, remember the negative could go in the denominator or out front or up top. So if you really wanted to, you could put the negative out front and make it look like this. Although technically we don't really put the 1 in the denominator if it's positive. So another way to write this answer would be a negative parenthesis x plus 10. Because technically we don't really put the denominator if it's a positive 1. Or the other thing you could have done is taken the negative through the entire numerator and had negative x minus 10 as the final answer. So technically all of these are correct. I'm thinking that my math lab will like these two answers better than if they put the negative in the bottom or the negative out front with the positive 1 in the denominator. It's just my thought. Okay? Yes, Mr. Armstrong. Cool. Glad you guys all agree. All right, let's talk about number 5. So number 5 says find the values. So we've got 4 values here. So we've got this f of x equal to x plus 12 all over 2x minus 1. And then we got this f of 4 equals this f of 0 equals this f of -3. So what are they wanting us to do here?
They want us to substitute for the first one. Wherever we see x, we plug in 4. And for the second one, wherever we see x, we're going to plug in 0. And for the third one, wherever we see x, we plug in -3.
Yay. That's exactly what they want you to do because this represents the x variable. So wherever we see an x in here, just like what Rochelle said, we're going to put a 4. So we're going to have 4 plus 12 all over 2 times 4 minus 1. Wherever there was an x up here, I put in the 4. So now you do a little bit of math. 4 plus 12 is 16. 2 times 4 is 8. And 8 minus 1 is 7. And I messed up. I wrote 17 on the top. Silly Mr. Armstrong. Again, this is why we don't do things in pen. Because it makes a mess. 7, 16. So the question is, does 16 over 7 reduce any? Because you got to make sure that you always reduce in the end. 16 over 7 reduce any?
You have 17.
No, it says 16 over 7.
It's just going slow.
Oh, am I running slow?
Yeah, it's very laggy.
I'm so sorry. Is it caught up now where it says 16 over 7?
Yeah.
So does that reduce?
No.
No. So that's your answer for f of 4. And then all we do is we repeat the process. So we're going to put wherever we see an X, we're going to put in 0. So we got 0 plus 12 all over 2 times 0 minus 1. So what do we get in the
Yeah.
numerator?
It's moving slow.
Yeah,
Okay.
the list.
Sorry. Is it caught up now?
No, it's been lagging like this whole time.
Means I'm probably gonna have to re-record this. Well, what about 0 plus 12? What do we get?
12.
Okay. And 2 times 0 minus 1, what do we get?
1.
Say again, Michelle.
-1.
-1. So in the end, what is the answer for f of 0?
-12.
-12. Yay. Is it speeding up a little bit better now?
Yeah.
Okay. So again, this time we just plug in -3. So we got -3 plus 12 all over 2 times -3 minus 1. So in the numerator, -3 plus 12,
9.
-9, or no, sorry, you're right. +9. +9. And in the denominator, 2 times -3 minus 1.
-7.
7.
-7. So does this reduce?
No.
No. So this is a-okay. Again, as we discussed a moment ago, the negative could come out front,
9/7.
or the negative could go into the numerator. All those answers are a-okay. Any questions on number 5?
Nope.
All right. Moving right along. So number 6. So dividing. So we've got x squared minus 6x minus 16 all over 2x squared minus 128 divided by x squared plus 10x plus 16 all over x squared plus 16x plus 64. How do we divide rationals?
You flip the second term and then change the divide sign to a multiply sign.
Yay, yeah, keep change flip, Kentucky chicken fried. Yeah, keep change flip. So we're gonna keep the first one the same, change this to multiplication, flip the second guy. So let's go ahead and do that. So we got x squared minus 6x minus 16 all over 2x squared minus 128. So keep, change, flip. So we got x squared plus 16x plus 64 on top, all over x squared plus 10x plus 16 on the bottom. All right, now what are we going to do?
It's moving slow again, but okay.
Sorry about that. So we did keep, change, flip. So what are we going to do now once I have done the keep, change, flip? Where I kept the first fraction, changed it, and then flipped the second.
We factor them.
You got it. We got a factor. Everybody factors. So we need to know, what does x squared minus 6x minus 16 factor to?
X minus 8, X plus.
You got it. X minus 8, X plus 2. Now the question is, what does 2x squared minus 128 factor to?
Two open parentheses, x minus 8, close parentheses, open bracket, x plus.
X plus 8 again. There you go. Yeah, you got to pull a GCF of a 2 out, and then it becomes a difference of squares of x squared minus 64, which x squared minus 64 factors into x minus 8, x plus 8. Perfect. How does x squared plus 16x plus 64 factor?
X plus 8. X plus 8.
There you go. Yeah, both of them are x plus 8. And in the denominator, how does x squared plus 10x plus 16 factor?
Open parentheses, x plus 8, close parentheses, x, open parentheses, x plus 2, close parentheses.
There you go. All right, now that everything is factored, what do we do?
Simplify.
Okay, how do we do that?
Cross out.
Who's growing away then?
The X minus 8, X plus 2s.
Because these two x minus 8s take each other out. This x plus 2 takes out that x plus 2. Who else is going away?
X plus 8, x plus 8.
Yeah, both of the x plus 8s. Because these two will take each other out. And those two will take each other out. So what is left?
Are you writing on the page or is it?
Yeah, I'm writing. It's
Sorry,
probably
it's just
lagging.
really far behind.
I'm sorry. So the x plus 8s are all gone. The x minus 8s are all gone. The x plus 2s are all gone. So what's left in the numerator?
X plus 8.
Nope. You
0,
crossed all of them. It's not 0.
a 1.
A 1. Remember when
1 over 2.
remember when everything gets crossed out in the numerator, all that's left is 1. What's left in the denominator?
2.
2. So it simplifies
It's a
down.
half.
Simplifies down to a half. That's it. Any questions on number 6?
Nope.
Okay. All right, number 7. We're adding two rationals. So we got this x squared minus 9x all over x minus 3 plus 18 all over x minus 3. This one's kind of nice. It's a nice multiple choice answer. Okay. Although, Deanna, it looks like you added in a complex fraction here. This should not be here. This 3 over x plus 7 divided by 9 over x squared minus the 49. That should not be there. That's a complex fraction. We're simply doing the adding that's going on up here. Yeah, we should be okay. So ignore this little part that's right underneath our adding of rationals.
Sorry
All
for
right. It's okay. And I think these answers should be okay. Maybe not. No, they should be okay. Yeah, they're fine. These answers do go with our adding problem, so it's fine. Okay. So how do we add rationals?
We're gonna factor it. Oh, it's the same denominator, so we're gonna combine the numerator together.
There we go. Yeah. Can't factor yet. So not like the multiplication and division we had earlier. We can't, no factoring yet. But moreover, these denominators are already factored as it is anyway. But like what Rochelle noticed is that they already have that common denominator. All we have to do is combine like terms across the numerator. So up here in the numerator, is anybody getting together with x squared?
No.
No. So we're going to write it down. Is anybody getting together with negative 9x?
No.
So we're going to write it down. And then plus 18. Anybody getting together with the 18?
No.
So we're going to write it down. So there's our numerator. No one got together, but they don't disappear. We got to write them down. Now is the time where we go back and we do what we have done earlier on two problems where we want to simplify. Once we get these two together, now we simplify. Now is the time where you want to factor this. The question is, what does that numerator factor to?
X minus 6, x minus 3.
You got it. X minus 6, x minus 3.
Over x minus
All
3.
over the x minus 3. You got it.
Cancel.
So what goes away?
X minus 3.
Yay. What's left?
X minus 6.
You guys got it. Which in our multiple choice, I believe was D.
D as in dog.
Yeah, D. So there you go. So number 7, the answer simplifies down to x minus 6.
It's like,
All right. Number 8, we're adding and subtracting again. So we got 7x all over.
it's just moving in slow motion, Mr. Armstrong.
You're
I'm
still writing
sorry.
x minus 6, x minus 3.
Oh my gosh, it's not even caught up to that. I'm so sorry.
It's okay.
It's like stop there.
It's like stop there. It's not moving anymore.
Oh no, now you're crossing out the x minus 3, so you're almost caught up, I think.
Okay. Good deal. I apologize for the lagging. Again, my computer's being very weird on the side. Like I have no control of my Zoom. It's like it's frozen in time over here, but yet everything still is going okay. So I'm not going to touch it until we're done since we're recording and everything. Although this is going to be a horrible recording. I'm probably going to have to re-record it.
Okay, you're back
Again,
on the
some other
problem
time.
8 now.
Okay. So you guys can see problem 8.
Yeah.
All right. So we've got 7x all over 2x squared minus 13x plus 6 plus 5 all over x squared minus 3x minus 18. Let's see if maybe I can help it out a little bit by getting rid of the calculator. There we go. Maybe that'll help speed up things a little bit. Less applications open on my side. All right. So again, we've got this 7x all over 2x squared minus 13x plus 6. And we're adding that with 5 all over x squared minus 3x minus 18. What do we got to do first?
Get the denominators the same.
We got to get these denominators the same. So that means we need the LCD. But before we can get the LCD, what do we have to do?
Factor.
Factor. The question is, what do these factor to?
2x minus 1.
Say it again.
2x minus 1.
2x minus 1,
X minus 6.
x minus 6. And that'll work. And then over here, what does x squared minus 3x minus 18 factor to?
X plus 3, x minus 6.
X plus 3, x minus 6. So what is the LCD going to be between these two fractions?
X minus 6. I'm
So
just
x minus 6 is part of it. Remember, the LCD has to be made up of everybody.
2x minus 1, x minus 6, and x plus 3.
There you go. So the x minus 6, the 2x minus 1, and the x plus 3. All three of these parentheses are your LCD. I just ran out of room. So we'll have x minus 6, 2x minus 1, x plus 3, and x minus 6, 2x minus 1, x plus 3. Everyone okay so far?
not really.
Not really. Where did I lose you?
Okay, we're good.
We're good? We sure?
Yeah.
Okay. So here's my denominator. It's 2x minus 1 and x minus 6. Here's what I want. I want x minus 6, 2x minus 1, and x plus 3. So what's missing for this guy? What's missing in our denominator up here?
X plus 3.
So we got to multiply this guy by x plus 3 on the bottom and x plus 3 on the top. So what's going to happen when I take x plus 3 times 7x?
21x.
Say it again.
Gonna be 21x.
21x. Okay. So there's part of it.
7x squared.
And 7x squared in the front. Yeah, you got to distribute this guy through. The 7x will multiply the x, and the 7x will multiply the 3. So 7x times x is 7x squared. 7x times 3 is 21x. All right, here's my denominator. I've got x plus 3. I've got x minus 6. But I need x minus 6, 2x minus 1, x plus 3. So what's missing?
2x minus 1.
Okay, so I need to multiply the top and the bottom by 2x minus 1. So what's going to happen between the 5 and the 2x minus 1?
It's gonna be 10x minus 5.
Okay. Because again, you just distribute. 5 times the 2x is 10x, and 5 times the negative 1 is negative 5. All right, we have common denominators. What are we going to do with the numerator now?
We're gonna combine them.
Okay. So just like what we talked about before. Anybody going to get together with the 7x squared?
No.
So 7x squared. I got 21x
10x.
and a 10x. So what does that give me?
31x.
And I got a negative 5.
It's gonna remain negative 5.
All right. Now what?
Gonna combine the denominator, I guess.
We're gonna combine the denominator. No, don't combine the denominator.
Factor.
Yeah, we need to see if this factors. That's the question. Does that factor right there?
No.
No, it doesn't. So what's that mean for our final answer?
It's just that.
Yeah, you're looking at it. This is the final answer because there's no canceling. This doesn't factor, so there's no crossing stuff off. Cool beans?
But I don't know where you at.
I know. Should we like exit out and come back in? Because like, why? Yeah, it's like nowhere near.
All right. Let's get caught up on this one and then we'll do that.
Yeah, you can just show us when you finish.
Okay, where are you guys at? Where's the video at right now?
It's still.
Oh,
right.
you're multiplying 2x minus 1.
Oh, joy. Well, we'll let it get caught up and then we'll go from there. Deanna, I would make a note that we're definitely going to have to edit this video maybe, or just re-record it some other time. Did it catch up?
Not yet. You're adding the terms up top now.
Well, that's good. Is it all there now?
Yeah.
Okay. So,
We're making the box around it.
perfect. So I'm going to close everything down and I will come back in.
Okay. Can you guys hear me now? Yeah, you're moving again.
Okay, that's good. All right, let's try doing this again. That means good. I've got control over things now. That's a good thing. Shrink you guys down. There we go. All right, number 8. Sorry, that was number. We did number 8. Why is we're on number 9. All right, there's that number 9 question that we saw, or there's that complex fraction question we saw earlier. So it's actually number 9. So we're going to simplify this complex fraction down. So we got 3 over x, and then we're going to add 7 to that. And then all of that is being divided by 9 over x squared, and we got minus 49. Okay. So how do we simplify complex fractions? What are we going to do? What are we going to do here?
Are we gonna factorize?
No factoring. Not yet.
Find the LCD.
Find that LCD, because remember, we're going to clear the fraction. That's the goal of simplifying complex fractions. We want to clear the fraction, okay? So that means we need the LCD. Of course, now my pen doesn't want to write. Why not? All right, so what's the LCD going to be? You only have 2 denominators. You got x and x squared. So what's the LCD going to be?
X.
X squared.
X squared. So now you play Oprah. You get an x squared, and you get multiplied by x squared, and you get multiplied by x squared, and you get multiplied by x squared. Everyone gets an x squared. Yay. So let's find out what happens. What's going to happen between the x squared and the x?
One is gonna cancel out each other.
One is going to cancel out the other. Do all the x squareds get canceled out?
No.
No, just
No,
one.
just one. So that x goes away, and that really just becomes a number 1. So what do I have left here?
3x.
3x. All right. What's going to happen between the 7 and the x squared?
7x squared.
All right. So a positive 7x squared. Okay. What's going to happen between this x squared and this denominator of x squared?
It's
They
gonna
cancel.
cancel out.
Yeah. Now they all go away. Left with
9.
9. And then what's going to happen between the negative 49 and the x squared?
49x squared. Negative.
All right. And so this is where you will now factor, because you're just going to simplify that rational. So this is what needs to factor. So how does this numerator factor?
X plus 3 and
Say it again.
X plus 3 and X plus 7.
Nope. It's not x
No.
plus 3, x plus 7. I like the x that you said.
X,
what's that leave me with?
3 is 3 plus 7x.
There you go. Yeah, it's just a GCF up there. Pull out the x. Okay. So what about down below here?
3 plus 7x and 3 minus 7x.
You got it. 3 plus, I don't know why I put another 3. Silly Mr. Armstrong. 3 plus 7x, 3 minus 7x. You got it. Come back and put that 7 in just a second. Okay. So what's going to happen now?
I'm gonna cancel the
Who's
3
canceling?
7.
Yeah. Those two cancel. So all you got to do is tell me what's left.
Minus 3 minus 7x.
What's in the numerator first? X. There's an X up top. And in in the denominator, we have 3 minus 7x. There you go. That is perfectly a-okay. Everyone good?
Yeah.
All right. So moving on to number 10. Almost done with those rationals. Right here in the solving equations. All right, number 10. So we want to solve this, okay? So we want to figure out what Z is. How do we do that? So we got this 7 over Z plus 1 over 11 equal to 6 over Z. How do we solve?
Do for LCD?
Do the what?
LCD.
The LCD. All right. So what is our LCD going to be?
11Z.
11Z. You got it. So you get 11Z, and you get 11Z, and you get 11Z. I don't know why I was making a hashtag sign. So there we go. We'll make that look like an 11. All right. So what's going to happen between the 11Z and this Z?
Cancels the Z.
Cancels the Z and leaves us with
11.
77. Okay. What's going to happen between the 11Z and the 11?
Eleven gonna cancel 11.
11's going to cancel out. And what do I get with Z times 1?
11.
1Z.
There you go. Just Z or 1Z, your choice. What's going to happen between the Z and the 11Z?
The Z's cancel.
Z's cancel out.
Huh?
And what are we equal to over here?
The 6.
66. Okay. What now?
You want Z by itself, so you're gonna subtract 77 on both sides.
So Z is equal to?
Negative 11.
Negative 11.
All right. Now what's the one thing you have to check?
If it goes into Z.
Not if it goes into Z.
If
But-
it's equal to 0, it's not.
There you go. So if I take and I put 11 in for the Z that was under the 7, I get negative 11, and in for the Z. The question is this okay? So I replaced where the Z's were with negative 11. So is that okay?
It's equal to 0, so.
Do any of these equal 0?
No.
Nope. So then this answer is just fine. Because this is not 0. This is not 0. That's what you're checking. Okay. So since these two were not 0, this answer is good. Checks. Number 11. So out here, you just select A and you'll put negative 11. So on number 11, we got to solve the following. 1 over X minus X over 121 equal to 0. Okay. So here we go again. How do I solve this?
LCD.
LCD. What's the LCD going to be?
121x.
You got it. So everyone gets multiplied by this. You get 121x, and you get 121x, and you get 121x. Okay. So what's going to happen between 121 and x?
It's just
X
121.
gonna cancel.
Yep, x is going to cancel out. Gone. So it leaves us with 121 minus what's going to happen between the 121x and the 121.
121 is gonna cancel out each other.
Gone. Gone. And x times x?
2x.
X squared.
Yeah, x squared, not 2x, x squared.
Yes.
And what's going to happen between 0 times 121x?
0.
0. And there we go. Now what are we going to do?
We can. You can either bring over anyone you choose.
We can do what?
Subtract 121 or add x squared.
Okay. So we can do that. Minus 121 minus 121. So that gives us negative x squared equal to negative 121. Now what?
You're gonna multiply or divide each side by -1 because you want the x to be positive.
That's right. So x squared is equal to a positive 121. And now what?
You're gonna square each side.
Square root
Square
each
roots.
side. So x is equal to what?
What?
What's the square root of 121?
11.
11. And it's plus or minus 11. There are two answers that happen with this. It's plus or minus. You'll see more of that when we get into module 4 and we talk about solving quadratics with square roots. The other thing you could have done right here is you could have factored this to 11 minus x and 11 plus x equal to 0. It could have factored. And so you get 11 minus x equal to 0 and 11 plus x equal to 0. This guy becomes the positive 11, and this one is your negative 11. All right, now the question is, are these answers A-okay? So we got to check it, right? But you got to check both answers. So if I put in the positive 11 first, so is this okay?
Yeah.
Yes, because that's not 0. And if I check the negative 11, oh man, ran out of room. Hold on. So if I plug in the negative 11, that's really the only spot that we're kind of plugging into. So is that okay?
Yeah.
Yes. Because again, as long as we're not 0 underneath, so these answers are just fine. So in your blank, you'll put negative 11, comma, positive 11, or just 11 because it's positive. All right, number 12. Number 12. So we got 1 over x equal to 1 over p plus 1 over t. They want us to solve for x. So you're not going to get a number answer. You're going to get a formula. So how do I start to get x by itself? What do we got to do? What do we got to do?
Multiply both sides by x.
It's going to be a little bit more than that, Litzy, but I like the idea. So it's not just x that gets multiplied on both sides.
The P and T can multiply
Yeah.
both.
You got to get that LCD. We got to get rid of all these fractions. So we're going to multiply everybody by the LCD, just like before, which is x, p, and t. So you get multiplied by xpt. You get multiplied by xpt. And you get multiplied by xpt. So what's going to happen between xpt and x?
The X's cancel.
So the x's
Okay.
cancel. What's left then here?
PT.
Yeah.
pt. Equal to, what's going to happen between the xpt and the p?
Gonna cancel.
All right, the p's go away. So what are we left with?
XT.
Xt, good. Plus, what's going to happen between the xpt and the t?
T is gonna cancel XP.
Okay. Now, remember, our goal is to get x by itself. But I've got two of these. What do we need to do?
Gonna factorize.
Factorize. You got it. Factor it. So what am I going to do to the side?
Gonna have X,
X. And then what's left?
E, and P.
T plus P.
T plus T.
All right, we're almost done. How do I get x by itself? Because now I only have one.
Gonna divide it by both sides by T plus P.
T plus P. Yeah. And there it is. X is equal to T plus P. Or sorry. PT all over T plus P. That's what's going in the blank. Good work. One more problem and then we are out of rationals. One more problem and then we are out of rationals. So number 13. So it says Maddie Evans drove 250 miles in the same amount of time it took a turbo propeller plane, I'm sure that's a plane to travel 120 miles. The speed of the plane was 190 miles per hour faster than the speed of the car. Find the speed of the plane. Okay. So in this problem, there is a formula that you have to remember. And that formula is that distance is equal to rate times time. You need this little formula. It's how we're going to get through this. Okay. So we've got two pieces here. We got a car. We got a plane. Right? Yes, you're right. I know. So for the car, do we know how far it drove?
Yes,
How far?
250.
Okay. 250. Do we know how fast the car was going?
No.
No. So we'll just leave that as R. Do we know the time the car took?
No.
No. But we do know that whatever time it took the car to travel is the same as the time it took the plane to travel, right?
Yeah.
Yes, right here, because it says same amount of time, car, plane. All right, so that's going to be key for us. Let's talk about the plane. Do we know how far the plane traveled?
Yeah.
Yes, how far?
1,200.
1,200. You got it. Do we know how fast the plane was going?
190.
How much?
190 miles faster than a car.
So 190 miles faster than the car. You told me we didn't know the car's speed. So what is the speed of the plane then?
R.
Say it again. Say it again.
190 times R
Not times R,
divided by R.
not divided by R,
Plus R.
plus R, because it's faster than the car. This is the speed of the plane. 190 miles faster than the car speed. So whatever the car was going at 190, you get the plane. Does that make sense?
Yeah.
And then we don't know the time. What's the one piece that was consistent between these two?
The distance.
Not the distance,
The speed.
not the speed.
Oh, the time.
The time was the same for both of these. However far the car went, or however long the car traveled, the plane traveled the same. These two were the same, right?
Yeah.
Yes. All right. So get this t by itself then. How do I get t by itself? What are we going to do with this r?
You're gonna subtract it on both sides.
Nope.
Oh, divide.
Divide, because it's multiplication. So we know the car's time was 250 divided by r. Get this t by itself. What are you going to do?
Divide the 190 plus R by 1,200.
You got it. So the plane's time is 120 divided by 190 plus r. Since both of these are the same, I can set these equal to each other. There's our rational that we need to solve. And again, I could do this. I can set them equal because their times are the same. How do we solve this?
Can we cross multiply?
You can cross multiply. Absolutely. That's what I would do. Okay, cross multiply. Or you can multiply both sides by the LCD and go at it like that. Which the LCD would be R and 190 plus R. It's all the same. But let's go ahead and cross multiply. That's the easiest to do. So what's R times 1,200?
1,200 R.
Okay, 1,200 R equals, what's 250 times 190 R?
$47,500 R.
47,500 what? plus, because you're distributing,
What's R?
plus 250 R. You got to distribute through. This is like a giant parenthesis. 250 times 190 is 47,500. 250 times R is 250 R. Does that make sense?
Mhm.
All right, now what?
Done.
Subtract
You
250R.
Oh.
Mhm. So subtract the 250R. And what does that give us over here with the R?
950R.
Uh-huh. Equals 47,500. And now what?
You divide both
divide.
sides by 950.
Yeah, you guys got it. You got it now. Divide by 950. 950. R is equal to what? 50 miles per hour. But is that who we're after? Who did we want in the end?
Time.
No, not the time. Let's go back and look. It says find the speed of the plane. So was the plane speed 50 miles per hour?
No, so you just plug it back in.
Yeah, that's the car speed. Remember, R represented the car. If I want the plane, I got to do what with the 50?
The 90 plus R.
Yeah, I got to add 190 to it. So this is really the car's speed. So the plane speed
240.
is 190 plus 50, which is what?
240.
240 miles per hour. And that's what goes in the blank. Okay. So the big key on this one is remembering this little formula right here. And that will be the same formula you should see on your exam. D equals R times T. That's your hardest problem on this thing, number 13. Any questions about number 13? Okay. $14, here we go, radicals. Jumping into radicals. So it says it wants you to find the cube root of this. So what can you easily do? How can we find the cube root of that number?
Can we bring out the negative outside?
You can bring the negative outside. So we got the cube root of negative 1,000. So you told me to bring the negative outside. Absolutely, we can. So that gives us the negative cube root of 1,000. So now what?
And just cube it.
Cube it. What do you mean just cube it?
Like just find the cube root, which would be negative 10.
Okay. Yeah, that's right. You could have actually just from the very beginning used your calculator because the cube root of 1,000 is actually 10. So the answer is negative 10. Use your calculator. Use the calculator. Let it help you out. Okay. Everyone good so far?
Yeah.
Number 15. They want this in scientific notation. 67,167.
Ooh, here we go.
So how do I get this into scientific notation?
6.7.
Okay. So how'd you get 6.7? What'd you do?
You jump from the point is behind the 7.
Okay, so the point is right over here behind the rightmost 7. So what do I do with this decimal point?
You're gonna move 4 times to the left.
So 1, 2, 3, 4. Because we need a number that's between what?
1
and 10.
1 and 10. 1 and 10. And 6.7167, because you want all of those, is between 1 and 10. Times 10 to the what?
4.
To the 4. Because we move to the right, and that's a positive exponent. And there it is. There's the scientific notation. So in your blank, you'll put 6.7167 times 10 to the 4th. All right. Number 16. We got this negative 27 to the negative 2/3. How can we figure out the answer?
I don't know. Put it in your calculator.
Yeah, right? Put it in the calculator. All they want you to do
It's undefined. It can't be
is
solved.
simplify if possible. No, it's not undefined. You put it in the
Negative
calculator,
1/9.
what do you get? Say it again.
Negative 1/9.
Negative 1/9? No, it's not a negative 1/9. But you're close.
Positive 1/9.
Positive 1/9. Use
I didn't put the brackets.
Yeah, you gotta watch that. Brackets. Use your calculator. Okay? But if you're doing it by hand, this is what you should know. First off, whenever you have a negative exponent, remember that means that they move. Negative exponents move. Right now, this is in the numerator. Where is it going to be happy then? This is in the numerator of a fraction. Where is it going to be happy? Where does it have to move to?
The denominator.
The denominator. So you get a 1 on top, and then all of this moves down below, and the exponent becomes positive. Now, we talked about this, and that whenever you have a rational exponent, you can turn it back into its radicals. And so the top number is the power, the bottom number is the root. And so you can write it like this: cube root of negative 27 squared. Or you can write it like this: cube root of negative 27 squared. It doesn't matter which one you use. You're going to get the same answer either way. So if I take the cube root of negative 27, that gives me negative 3. And then if I square that, that gives me the positive 1/9. Because negative 3 times negative 3 is 9. Down here, negative 27 times negative 27 is 1 over the cube root of 729. And if you take the cube root of 729, it's 9. So either way, if you're thinking about it, that's how it works. The answer is 1/9. Again, just use your calculator. Let it help you out. Almost done. Almost done. We're almost there. 17. So this says to rationalize. How are we going to rationalize number 17 when we have 8 all over 3 minus the square root of 11? How do we rationalize this? And let's see, you might be the only one that might know the answer to this.
Multiply it by 3 minus the square root of 11.
So close. It's not
Oh,
a minus. Yes, we got to use that conjugate. Whenever you have addition and subtraction with a radical in the denominator, you got to use conjugates. Okay, and the conjugate is just really changing the sign to its opposite. So a minus becomes a plus. And so all we got to do now is a little bit of distributing slash foiling, but we don't really do the full FOIL down here. Remember, I mean, you can do the full FOIL, but all that's going to happen when you multiply by conjugates is the middle term cancels out. All you really have to do is multiply the first and the last in the denominator. I call it the Florida. Because the middle term, the O and the I of FOIL will cancel out. So what's 3 times 3?
9.
9. What is a negative times a positive?
A negative.
Negative. And what is the square root of 11 times the square root of 11?
11.
Just 11 because they're the same. There you go. And 9 minus 11 gives us
2. Negative 2.
negative 2. Perfect. All right. Now, we need to distribute through on top. What's 8 times 3?
4.
24. And what's 8 times the square root of 11?
8 times the square root of 11.
You got it. So this is what we have in our numerator. Now, from here, this is where you first look at your radical. Can my square root of 11 break down? Can we do anything to break this radical 11 down?
No.
Good. Then you look at your numbers. 24, 8, and negative 2. Is there a number that can divide all three of these other than 1?
Oh.
2. So we're going to go ahead and reduce this. So what's 24 divided by 2?
12.
What's 8 divided by 2?
4.
And negative 2 divided by 2?
Negative 1.
Again, as we talked about before, this answer, it doesn't bother me any. It is technically correct, but it might bother my math lab. So you can do one of two things. You can move the negative out front, and this is still technically correct. But again, I said that we usually don't leave a positive one in the denominator. We kind of knock it out. So you can have a negative with a parenthesis 12 plus 4 square roots of 11. Or you can distribute that through and get negative 12 minus 4 square roots of 11. But all these They are good math. My advice to you is something probably like the bottom two, like what I talked about before. I don't think my math lab really likes the negatives in the being in the denominator, but technically there's nothing wrong with it. And the same thing with the negative out front and the positive one. We usually don't put positive ones in the denominator. We just knock it out. Good job. Good job rationalizing. Almost there. Number 18, we're going to solve a radical equation. So number 18, we got this cube root of 2x minus 19 minus 5 equal to negative 8. So we want to solve. No worries, we can do that. All right. So what's going to be the first thing we do? What do we got to do first?
Add the 5 to the 8.
You got it. Add this 5 to the 8 because we got to get our radical by itself before we can do anything. So now we have the cube root of 2x minus 19 equal to, what's negative 8 plus 5?
-3.
Negative 3. Okay. Now what? We got our radical by itself. What do we do now?
Cube root both sides.
But it's already a cube root, so we don't want to cube root it again. We just want to cube it. Because remember, a power of 3 will knock out the root. So the cube root and the power of 3 cancel out, leaving you with 2x minus 19. And what's negative 3 cubed?
Negative 27.
Perfect. And now what do we do?
Add 19 to both sides.
You got it. So 2x is equal to, what's negative 27 plus 19?
Negative 8.
Negative 8. Okay. And
And
negative 8
divide by
divided
2.
by, gives us.
-4.
Now you must check this answer, just like before. We got to make sure that this answer actually works. So we're going to check the full thing. We're going to make sure that we get a negative 8 in the end. So we got 2 times negative 4 minus 19. So what's 2 times negative 4?
-8.
And what's negative 8 minus 19?
-27.
And what is the cube root of negative 27?
-3.
So if I take negative 3 minus 5, will that give me negative 8?
Yes.
Yes. Negative 8 equals negative 8, so it checks out. So this answer of negative 4 is a-okay. Any questions on 18? All right, number 19 is solve a radical word problem. Solve a radical word problem. But the best part about these is that it actually gives us the equation in it. We don't have to develop our own. Just kidding. It didn't give us the equation. So it says a spotlight is mounted on the eaves. Oh, never mind. Well, we will use radicals to solve this. But this is a Pythagorean theorem problem. That's what number 19 is. Pythagorean theorem. So it says the spotlight is mounted on the eaves of a house 24 feet above the ground. A lower bed runs between the house and the sidewalk. So the closest ladder that can be placed to the house is 18 feet. How long is the ladder? Excuse me. How long a ladder is needed so that the electrician can reach the place where the light is mounted? Okay. I assume that's a flower bed, not a lower bed. All right. So when it comes to Pythagorean theorems, remember the easiest thing to do, draw a picture. So it says we have a house, a spotlight, a flower bed, sidewalks. Okay. So let's draw a little picture here. Draw my little house, windows, doors. All right. So there's some sort of spotlight. Here's my spotlight. Okay. Then over here, there's like grass and flowers. Whee! And then there's a sidewalk. Okay. So let's fill in some information. How high off the ground is the spotlight?
$24 feet, I
Okay.
think.
It is. So from here to here, it's 24 feet. Okay. It says the closest the ladder can be to the house is 18 feet. Okay. So out here, should have made my flower bed longer. Flowers. My ladder how far away is my ladder from the house? What does it say?
18 feet.
It's 18 feet. We want to know how long is the ladder? So do you see your right triangle here? Right in there. So what is the Pythagorean theorem?
A squared plus B squared equals C squared.
Yay. Okay. So let's do some quick labeling. What is the 24?
A.
Okay, we can call it A. What is the 18?
B.
B.
B, good. Because these are legs. The legs help form the right angle and the ground and the height of the spotlight. This is the right angle area. Okay, so these are definitely the legs. We're looking for the hypotenuse. So we got 24 squared plus 18 squared equal to C squared or question mark or X, whatever you want to call it. So 24 squared is 576 plus 18 squared, 324 equal to C squared. Add those two numbers together.
900.
Equal to C squared. And then now what?
You're gonna square root each side.
You got it. So C is equal to, what is the square root of 900?
30.
30.
Good job. 30, and it would be feet. That's how long our ladder has to be. And if it came out to a decimal, you would round accordingly. But this one actually doesn't say anything about rounding because we didn't have to round. It was nice and neat. The number was 30. Any questions so far? All right, number 20. Litzy, I'm gonna have you help me help us on this because some of my students haven't reached this part yet, but you guys hopefully might have seen this already. So we've got this 4 minus I all over 6 minus 5I. And we want to write this in this form. This is what we call standard form of complex numbers. I is a complex number. I will let you know this problem is a lot like what you did right here on number 17. I represents a negative square root, or actually the square root of -1. So we got a square root in the denominator and we do not like that and we have to fix it. Okay. So we've got this 4 minus I, 6 minus 5I. Remember, I represents square root of -1. That's what's going on there. So how do I rationalize this denominator? Because we do not want the I down here. How are we going to rationalize this? What do we got to multiply top and bottom by?
Multiply it by 6 plus 5i.
You got it. We're going to go back to conjugates. And so what's the conjugate of subtraction? Addition. So we're going to multiply top and bottom by what we call the complex conjugate because we have i's this time. Very good. So let's talk about what we have left. So in the denominator, because these are conjugates, we only have to multiply the first and the last. So what is 6 times 6? Anyone can answer?
36.
36.
36.
What's a negative times a positive?
Or negative?
Negative.
Negative. 5 times 5?
25.
And I times I?
I squared.
I squared. Now, whenever you have an I squared, I need you to remember that I squared is really just a -1 in disguise. So this denominator really looks like 36 minus 25 times a -1. So in that denominator, what's a -25 times a -1?
Positive 25.
Positive.
So my denominator really is 36 plus 25, which is what?
61.
61. All right, now let's work on our numerator. So up here, we're going to have to FOIL this out. So what's 4 times 6? 24, good. What do you get when you take 4 times 5i?
20i.
20i. Yeah, it's just like multiplying by a variable. 20i. What's negative I times 6?
Negative 6i.
And then what's negative I times 5i? Say it again.
Negative 5 minus 1, because it's going to be I squared.
Negative 5i squared. We'll get to that. And then yes, just like what you said, that I squared there is really a -1. And what happens with a -5 times a -1?
Because of positive 5.
So what we have is 24 plus 20i minus 6i plus 5. Let's do a little bit more cleaning up. The 24 and the 5 can get together and become what?
29.
29. And then the two i's can get together. So what's 20i minus 6i?
14i.
Okay. So the question is there a number that divides 29, 14, and 61? Is there a number that can help me reduce these?
No.
No.
No. So again, since there's nothing that can reduce these, we're almost there. Our answer has to look like A plus BI. So what we're going to do to this is we're just going to separate this into the two fractions. So one of your fractions will be 29 over 61. This is what we call A. Plus, because there's a plus there, the other fraction will be 14 over 61. And then the I will go out right beside it. This is the BI part. That's what they're looking for. So you do have to separate it out. They do not want that. Any questions about the complex number? And that, my intermediate algebra 1 friends, is your exam 3. Yay, we made it.
Yay.
So let's see if I can pause the recording. Actually, I can stop it. There we go.